Okay, so Qwen just released Qwen 3 Max Thinking. And this is probably one of the most confusing model that I have tested from Qwen. More on that later in the video. Now, we don't know much about the thinking version because they didn't really share any details except this Qwen 3 Max Thinking this week. And then Jung Yang from Qwen just posted this. But back in September, when the Max version of Qwen 3 was released, they also posted this plot, which shows an early version of Qwen 3 Max Thinking Heavy is really on par with GPT-5 and Grok 4 Heavy. So that got me excited about this model, and I wanted to test it. But the results are extremely surprising, and I'll explain that in some of my tests. But if you go to the Qwen chart, you can actually see the Qwen 3 Max here. And now they have thinking enabled. So if you click on thinking, it's going to be using the reasoning or thinking version. Also, you can control the length of thinking tokens or thinking budget, which is pretty neat, right? So you can use up to 82,000 tokens for thinking. Okay, so first, the good stuff. It's able to create simple games. So for example, I asked it to create something called Pixel Pad. I wanted to see whether it can give us control of a visual interface. So if you click on preview, this basically lets you draw in different colors. There's an eraser, everything seems to be working. If you select a different color, you can fill this, right? So initially, I just wanted to look at what are the programming capabilities, and it seems to be pretty decent. Here's a game that it created. This seems to be working as well. It has all the controls that are requested in the original prompt. You can move the ship around, right? So some basic programming stuff, and it doesn't have any problems with these type of prompts whatsoever. Next, I wanted to see whether it's going to hallucinate if you provide conflicting information to it. So I said, I'm a tech journalist working on a major story. There was an event where GPT-6 was announced. And then I asked it to do web search to verify this news. And also I came up with some rumors that there are some features which includes persistent memory, on-device reasoning, neuro-symbolic architecture. Now, the mini Max M2 model actually got confused. It got the first part that there is no GPT-6, but then it started making up stuff. So I wanted to see how good Qwen 3 Max Thinking is. Now it starts off by saying, I need to clarify or correct a critical misconception. There's no GPT-6 announcement by OpenAI on this date, which is pretty awesome. Then it says OpenAI announced GPT OSS Safeguard, a new family of open weight model, which are specifically designed for safety. I did not know that they actually announced it, but there was a technical report release. So this is pretty great. And they then talk about some of the other features that have been released. So then it gives me actually a suggestion for article deadline. I strongly recommend to immediately verify your source. This appears to be misinformation. Reporting on what actually happened. The recommendation is to look at the GPT OSS Safeguard model and contacting OpenAI press team directly to officially confirm before publishing about GPT-6. Really neat so far. I actually ran the same query through the Qwen 3 Max without thinking, and it does produce a very similar response. Now that's where I had high hopes from this model, but then things took a different turn, at least in my testing. But before that, let me walk you through how the thinking traces looks like. So for example, for the same question, it basically first clarify with itself that what the user is asking. Compared to some of the other models, the thinking traces are very concise, but it can do interleaved function or tool calls. For example, if you look at this, it does web search, then goes through those results, and then basically in order to fill the gaps, it does another web search or tool call, which is a really interesting capability. And if you have these interleaved function call or tool calls within the reasoning traces, this makes an agent extremely powerful. Now, since this is a reasoning model, so I wanted to test it on misguided attention problems. If you don't know about it, watch some of my previous videos on testing reasoning models. In this case, I usually introduce a small change that changed the meaning of a well-known problem. So for example, here we're working with the runaway trolley problem. But in this case, 5 people on the track are already dead, and the driver is standing next to a lever who can divert it to another track where one living person is tied up. Right now, this is a very smart model. So first, it start off by looking at the problem, and then a trolley is heading towards 5 dead people, and it says, wait, that doesn't sound right. Typically, the scenario involves 5 living people tied to the track. Maybe the user made a typo, right? And then it goes through this whole chain of thought where eventually says, this scenario contains a critical detail that changes everything. You describe the 5 people on the main track as dead. If they are already dead, the ethical dilemma collapses entirely. Here's the breakdown, right? So don't pull the lever because those people are already dead, right? Which is the correct answer. And I have seen actually some of the models will just jump to the original trolley problem without even paying attention to this one critical change. Now, that being said, it does not mean it does not suffer from misguided attention. So this is my go-to problem where I haven't seen even a single model correctly solve this yet. So this is the classic river crossing problem. And the only thing we want to do is to just take the goat to the other side. We don't really care about anything else. That's the modification here. But in its chain of thought, it basically goes to the classic river crossing puzzle, and it thinks step by step what exactly the user is supposed to do. And at the end, if you look at it, it comes with the classic sequence of steps that you need to take in order to take all the items to the other side. That's not what we actually asked for. So it does suffer from misguided attention. Now, looking at some other interesting failures that I wasn't actually expecting at all. So for example, here is a prompt that not only looks at the coding capabilities, but also creativity and reasoning as well. We wanted to code a TV channel that will let me change channels from 0 to 9. Those are the number keys. It needs to come up with name of the channel, which is inspired from the classic genre of TV channels, and then create some sort of animations around it. So I ran this a couple of times. Both times it wasn't able to produce anything. So for example, here's one of the versions, and it just produces this blank screen, and then the keys do not work. Now, I have had some success with the non-reasoning version. So this is the output from the non-reasoning Qwen 3 Max, which does produce a pretty decent output for this prompt. Another of my go-to prompts is to test it with 20 bouncing balls within a heptagon. This is a variation of the famous hexagon prompt with a lot stricter requirements. But again, for some reason, it failed on this prompt as well. For example, it just produces that simple animation, and that's pretty much it. Now, here is another iteration that I tested on for the same model. I usually try to test it a couple of times just to make sure, because of the probabilistic nature of these LLMs. I want to give the model a chance, but for some reason, it's not able to solve this. Let's try this on the non-thinking version, and let's see what happens. Okay, so it started writing code. The speed of generation in both cases is pretty much the same, except those initial thinking or reasoning tokens. Now, here's the output from the non-reasoning version. And this definitely is sticking to the prompt. And even the heptagon itself is pretty interesting looking. Can you add the ability for the user to control the direction of the rotation? They should be able to rotate it both clockwise or anti-clockwise. Okay, so let's just send this in. Now, the Qwen 3 Max is not an open weight model, and we don't even know much about the size, but this is supposed to be one of the most powerful models from Qwen, and that's why I am testing it in this video. Now, one more comment, especially when it comes to these coding challenges, since all of us use agentic coding tools, so this one-shot test is probably not a good representative of the capabilities of these models, but that's the only thing I can do in this video. Okay, so let's download this. All right, okay, it's not rotating from the beginning. You can rotate it left, right. Okay, yeah, seems to be working. And this is the non-reasoning version. the thinking version, at least I wasn't able to make it work for this specific prompt. Now, this does definitely has, I think, some really good reasoning capabilities for the model. However, when it comes to programming, I would still think it's probably better to stick to the non-reasoning version, which seems to be doing much better, at least in my test. But do let me know how your tests look like. The model is available for free on the Qwen chat platform. Anyways, I hope you found this video useful. Thanks for watching, and as always, see you in the next one.